October. So today we'll be discussing a newly released RFI, Slimmer, Stronger Snack Packs. As always with our webinars, we encourage you to submit questions throughout the webinar using the Q&A button at the top of your RingCentral window. We'll answer these questions at the end of the presentation, and you're welcome to submit more then too. Our speaker today is Innovation Development Manager and RFI Manager, Jason Guo. So Jason, I'll let you take it from here.
Thank you, Shivani, for the introductions. And my name is Jason Guo, and thanks everybody for joining this call. Today, the topic of the discussions will be about how to make a strong backs. So you can see in the picture, it's not a pleasant experience if you have a puncture backs and orange on the floor. Okay, at Xinova, we believe problems are a good thing, and here we are here to solve one of the technical challenges from our clients. This is an outline I will go throughout the webinar. We talk about the challenge and the background, and we will also discuss the current technology. Then we will focus on what's in the scope, what is out of the scope. We'll also touch the topic in the considerations for commercializations, and then end this webinar with a Q&A. So the challenge, dense snacks with sharp edge requires a thicker packaging material, and thus you have to use more materials. Classic snacks such as Fritos and pretzels, and in this particular case, I have the two images of pretzels. As you can see on the left-hand side of the image, on the pretzel, the surface of the pretzel, we have a crystal salt, which could be sharp. And during the filling or distribution, those sharp edges could cause punctures. And this is a challenge from our clients. As you can imagine, in this case, pretzel has a sharp edge, but then the other chips or other snacks, you might have a different requirement. I think in this case, pretzel is the most challenging one, and we'll particularly bring this up. Why this problem is valuable to solve, of course, is the first one is cost saving through the reductions of required materials. By thinning the materials 0.5 mil, it translates into 50 million saving per year for our client. So this is quite substantial. Also, puncture bags looks bad. It damages the brand, and consumers will be less likely to purchase the same product again. So here I'm showing you two resources of punctures, which are during the filling. The other one is during transport or distribution. On the left-hand side, this is a typical vertical form fill system. It's very fast. So you can see the snacks drop from the top to the bags and get sealed and cut. This vertical height is about 3 feet. One can try to calculate the velocity that reaches the bottom of the bag or the force, but the pressure really depends on how sharp the edge of the snacks is. The other source that is during the transport, the package experience vibrations, and therefore the sharp edge of the snacks are in contact with the bags. So so the collisions between the snacks and the bag, it causes the puncture. So both source of the punctures, both of them are basically the same mechanism. It's just a different scale. During the vertical fill, it's a one shot but high force. However, during the distributions, there are just many little shots. Between those two source of the punctures, puncture actually happen more often during the transport or distribution compared to filling. Packaging flex film construction. The image shows here is a cross-sectional of the film stack. The film or substrate is a polyolefin such as polypropylene or polyethylene. The inner substrate acts as an oxygen and moisture barrier to preserve the freshness, in addition to offering puncture resistance. So sometimes the manufacturer has to make the film thicker, not because of the moisture barrier, but it's just because we need to improve the puncture resistance. Where the outer layers displayed a marketing graphic. Then there's what's so-called bonding cushions or interlayers. This is where the opportunity is. These interlayers are overly thick to prevent punctures. Currently, our client uses an extrusion lamination process with hot melt polyethylene, and in the case of the pretzel snacks, they use a low-density polyethylene to make packages with an extra thickness so that they are softer and provide more cushioning. So there are two main ways to deposit the film or introduce the film to the substrate. The first one we'd like to talk about is extrusion process. Extrusions, on the left-hand side, the image here shows that the melted materials come out of the extruder, it's usually hot, and then get deposited into the film, and then get rolls so that the material is evenly distributed, and then get hardened. So you could do on the left-hand image, you can do multiple layers of process, but at the end, you're gonna have to bond two substrate, which are the outer layer and the inner substrate together. So what is shown here is that extruder spit out the materials, then it goes the two substrate. It gets sandwiched between the two substrate through the roller. Then the laminations happen. So there are also technologies such as single layer, but it is not as resistant to puncture. Therefore, at this moment, our client doesn't use it. The other approach to deposit those interlayers is through adhesive layer. The adhesive layer is typically 3 to micron thick. It is possible to go thicker. It really depends on the material's viscosity and particle size. So on the image here, I'm showing, you can see that the mixing unit, you can mix materials, and the materials, they get into a bath or spray that it sort of convert or moved to different rolls and then get deposited on the substrate. In this particular one, you go through a dry process, and then later on, lamination happens. There's little thought was given to puncture resistance in the current adhesive design. The minimum bonding strength in this particular R5 for the adhesive is 50 gram per inch, with 100 gram per inch preferable. However, I'd like to point out that this industry standard is usually 500 gram per inch. So this is adhesions is not the main challenge here. The main challenge is how do you improve the puncture resistance. There are 4 common processes for the adhesive eliminations, which include dry bonding, wet bonding, UV curing, hot melt, adhesion process. So adhesion laminations is preferred when a film cannot be effectively processed through a cold extrusion process because of equipment limitations, potentials for thermal damage, or when the use of the adhesives will benefit the final constructions. However, there are some important considerations. The first one is price. For example, Kevlar is just too expensive for the process. The second is the speed. The adhesive usually there's a limit of how thick you can deposit on it. You can apply thicker film, but it will take a longer time, and you will get a hit on the process speed. The other approach will be surface modifications. It can be used on low priority polymetric films and other substrates to improve the structural performance. Some of the methods include that is shown here, that is roll coatings, cold extrusion, immersions, and plasma treatment. There are other approaches such as chemical surface treatment, vacuum plasma depositions, vapor deposited oxide and nitride can also be used. So those are where the opportunities are. So here I like to talk about what is in the scope, Invention Suggestions. New coatings for films that will increase the puncture resistance. The other one is the puncture resistant adhesive. Earlier we talked about the adhesive process. If you can redesign the adhesive to focus not on the stickiness, but the puncture resistant, there will be some opportunity there. Also, we also talk about post-processing. For example, an olefin that can cross-link to increase the puncture resistance. So here I'd like to also point out, earlier I mentioned that for the adhesive, we talk about the bonding strength. The thickness, the bonding strength is, industry standard is for pulling strength is 500 gram per inch. Now here we have a less constraint on that, which is minimum of 50 gram per inch. Out of scope. So layers that are not recyclable, for example, nylon, if they are not compatible with the current manufacturing process, or they are too expensive, for example, Kevlar. In terms of the commercializations, there are a few considerations. Clients strongly prefer to use the same base substrate or film in the manufacturing process, manufacturing infrastructures. Equipment replacement or retrofit will require significant amounts of capex. It's not as preferred. Any of the new materials introduced must be recyclable and compostable. So with that, I would also, before I jump into Q&A, I'd like to encourage again, please utilize the pre-submission feedback, which is by clicking the highlighted button that is shown in the picture here. This is very useful. We certainly value all the inventors' time and effort. So please make sure that you reach out to us if you're not sure about whether it's in the scope or out of scope. That will save you a lot of time in doing so instead of jumping in writing of the full report. So with that, let's take the questions.
Okay, so thank you, Jason. So we currently don't have any questions, but I will wait a few minutes for you to think of a few questions and just submit it to the Q&A app.
So while we're waiting for questions, I'd like to point out I've received some questions regarding the details of the film structures or the interlayer structures. There is a balance. As you can imagine, the client has this technology, or the material they're using. Some of them is considered as confidential. There's a balance between what we can disclose, what they can disclose, and what they have to disclose. So you have that you can work on and solve the challenge. So they have told us the film thickness and the usage per weight on a per roll base, which is somewhat helpful. But I think it could be we could ask for more details. But then there's a challenge whether how much it can be disclosed.
Okay, so we have a couple questions from Alicia. So the first question is, are you interested in solutions that solve puncture from a drop versus rubbing during transport?
Are you interested that solve a drop of rubbing? I think both. I think I think in one of the slides I mentioned two sources of the puncture that's coming from the drop or filling, and the transport during the transport. I have also mentioned that during the transport is where it happens more often than the other one. I don't know if that answers your questions.
Okay, and the next question is, how much of the thickness of the inner layer is for puncture resistance versus barrier properties?
It really depending on the product. I think clients has told us that different product has different requirements. Currently what I showed, I think it was about 16 micron, that thickness, or 17 micron, that's sort of the thicker side for the pretzel, and those are the films for interlayer, not so much for the layer that as a barrier. I don't have the information how thick the barrier is, and what is the extra material they had to use that is overkill as a barrier, but is used for puncture resistance. I don't have the detail on that.
Okay, and our last question so far is, how big are the punctures? What are the size distributions of the punctures?
I have to say that I don't have the answer to this, but I think you can imagine the different snacks had a different sharp edge, salt crystals versus broken chips or broken for, because of the edge is just different. I don't have the statistics on when it happened, or how big the hole is, or what is the distributions of the size of the holes. I think it could also depending on the different product. I think an inventions that could improve the punctures for different product. It probably have a different extent of impact, but I think it should be applied to most of the product.
Okay. So again, feel free to send in some more questions. We'll wait another minute or so, but you're also welcome, if you have more specific questions maybe that you don't want to share in the webinar, you can always send an email to Jason with your specific questions.
Yeah, like I mentioned, I understand more clarity are preferred, more clarifications are preferred. I think it's just a balance how much can be disclosed. And if you have a technology that you don't know whether it could work or it could actually save the materials or not, I think as long as you can improve the puncture resistance but not increasing the materials, I suggest you reach out to us or write up the report. During the review, we'll have a better idea when we review with the clients on the details.
Yeah, and as always, if you can send it, a paragraph or piece of mission feedback, that's always the best way to, find out a little bit more before you invest in a full report too.